So I'd like to introduce the first speaker, which is Dennis Geurts, and he will present about his project Aelora. Very short about Dennis. He's a software architect at Luminous, based in Arnhem, and he's also the initiator of the Arnhem community of the Things Network. So I hand over the word to you, Dennis.
Okay.
All the best.
Okay, thank you, Lawrence, for inviting me to talk about LoRa. It's a proof of concept that measures air quality. I'll first start with introducing myself. Are you seeing this? Yeah. Okay. My name is Dennis Geurts. I live, as Lawrence said, in the east of the Netherlands, and I work at Luminous Arnhem. And these are the things I'm doing when I'm not working, earning my money. So on to the next slide. These are my colleagues. I didn't do the project myself by myself. Also, Jacco, Richard, and Ivo worked closely with me to accomplish this. So, what is LoRa? Aelora. LoRa is a proof of concept. We wanted to do an end-to-end project using LoRaWAN, and in the Netherlands there's on the 1st of October there's an annual technology day, and we wanted to showcase a LoRa technology on that day, which we did. So that's why we wanted to do an air quality sensor experiment, and for that we used a dust sensor. It's a sharp dust sensor. We connected it and hooked it up to the Arduino Nano, and used the microchip LoRa module, the RN2483, and sent several messages on different ports to measure the air quality. And of course, it was all inside a very nice package, a 3D printed bird. Well, it's nice for people to, it's much more appealing for people to look at. Okay. So the architecture is as follows. The LoRa birds uses LoRaWAN to connect to the Things network. It sends its messages to the Things network. Then these messages are handed over via MQTT to a Raspberry Pi, and this Raspberry Pi has a Node.js application running that sends all the data to the Firebase real-time database. And this Firebase real-time database also hosts a web application which you can look at, and it's really quite simple. It couldn't have been more simple to connect to it. So about future improvements for Aelora, this is really a proof of concept, just showing that we can do it from end to end. Energy consumption really needs to improve. We might be able to add some solar cells. Also, we used off-the-shelf components, which is always nice for prototyping, but afterwards you really should go to a custom-made PCB. And we really found out that air quality measurement is really difficult. It's not easy. So don't expect to that this proof of concept has been working all along. Furthermore, we want to do more birds, more data beasts. A colleague of mine, Ivo, he has also created Tamagotchi, which is a beast that monitors the humidity of your plants, and you better watch for your plants, because otherwise he will Twitter to your mother that something has gone wrong. So I think that's it. If there are any questions, I can answer them right now.
Well, thanks a lot for sharing this, Dennis. I think it's a nice project for which LoRa technology is very suitable.
Yes, it is.
So the question that's now popping up, so how do you define air quality? Like, do you have some benchmarking there, or how does that work for you?
Yeah, that was really hard. There's not really we weren't able to really calibrate the air quality standards. So that's something we really want to look at in the future. Also, I don't have an environment where I can really know that I have a particular amount of particle matters in the air concentration. So that's really hard.
Yeah, can imagine.
Yeah.
So, is it open source, and where to find it?
If it's not open source yet, but I can put it on GitHub. That's no problem.
Nice.
Yeah.
Perfect. So another question here is, so how would you target the optimized energy consumption in the future?
Yeah. Yeah. Well, for now we just plugged it into a power bank, which is not really optimal. I would like to add, for instance, a battery, remove the power regulator, stuff like that, and then really optimize energy consumption by killing the power in a different way. Right now, we just kill the power to the complete Arduino, but I think there are other ways to do that more optimal.
Yeah. Thanks. Maybe a bit of another question. So, what is your future vision of this project? Because I think, because you, as far as I know, you fetch it to a website where every person in their surroundings can like detect the air quality in their surroundings.
Yes, that's true. Yeah. Well,
what is your? Please continue.
Yeah. Yeah. Well, we can also make an app. We have been starting to do that so that you can get notifications when the quality is bad in the vicinity of your where you are. Also, if you have more birds, then you can predict more well over a larger area of space what the air quality will be, and you can probably also use the raw data to extrapolate more easily what the air quality really was.
Yeah.
But as I said, I'm not an air quality expert at all, so this is a difficult field.
Yeah, I can imagine. So I see another question popping in. So can you give an estimation about like what such a bird would cost now?
Okay. Well, internal components are something like $30 to $40, and I don't know what the 3D printed bird costs. I think it's also about $30 because it's low volume, so it was 3D printed. So $60, $70, something like that.
Right. Great. Thanks a lot for sharing this.
You're welcome.
So I'd like to go to the next presentation, and we have some questions at the end of this session. We have some time for some other questions as well. So if anyone wants to ask Dennis about more questions about this project, then you're free to do so. So next is our two presentations, or is a presentation from two people, one from Tjerron and from Kasper, both from Rainproof Amsterdam. They're working on a project, well, I won't tell not too much, but about micro water management in cities. So I had the pleasure with meeting them already quite a few weeks ago. Heard their presentation, was quite passionate about it, so therefore I asked them if they could share their work again during this session. So Tjerron and Kasper, go ahead if you want.
Yes, okay, good.
Here we are. Well, I'm Kasper Spaan, working for Waternet, the Amsterdam-based water cycle company.
Yeah, and my name is Tjerron Boxem, and I'm working for the program called Amsterdam Rainproof, which is a program initiated by the Waternet, or the Water Board of Amsterdam. And before we will elaborate on the project we're doing with the Things Network right now concerning the smart micro water management, we'll briefly discuss the problem statement at hand.
Well, we're facing climate change. We're not discussing that. We see densifying of cities, and that's the challenge at hand. And in those cities, we see roughly a 60-40 percentage in public and private space. In the public space, we see the government working on climate adaptation issues, but now we are focusing especially on the private space, where we see a lot of possibilities for water retention and water storage.
Yeah, so that still may sound very theoretically, but this was Amsterdam on the 28th of July in 2014, where a cloudburst hit the city with a total amount of 90 millimeters a day, but intensities went up to 135 millimeters per hour. And you have to think of that the sewage system is capable of only handling up to 20 millimeters an hour. So this was 2 years ago. Last year we also had a cloudburst, a smaller one than this one. But in total, those two cloudbursts would cost the city 50 million euros.
Often the solution is thought of, well, let's install a bigger sewerage pipe. Well, in the professional community of water management, it's considered not the solution. We should aim for more sponge-like cities where the whole surface area of the city is working for optimal water management. One of the first pilots where we learned the capabilities of micro water management was the polder roof. It was a water storage facility underneath the green roof as is shown. And one of the remarkable innovations we added was a valve-like system that could control the water level underneath the green area.
Yeah, and the idea of this polder roof is that we're able to contain the peak intensities of cloudbursts and can discharge them at a later moment whenever it's dry for a couple of hours already. Yes, these innovations are going on, but it gets really interesting whenever you can connect those standalone smart micromanagement systems with each other or with the cloud, and that's where the Things Network walks in. We found each other, and because if you want to connect them, you'll need this digital platform that is able to allow for plugging in different kind of systems, handling all the data, and also steering your rainwater. This could mean that if you zoom into the local context, this could be the future house, or you could also apply this to a company or a larger building, where house owners or product owners could install their preferences of whenever they want to discharge the rainwater, and they can choose whether to discharge to a combined sewer system or separate, depending on the geographical location of it. But they could also make the decision to discharge to the garden whenever it gets dry. There are many options and possibilities for smart micromanagement, and in order to prevent the overflowing of sewer systems.
This picture shows where we're focusing on, the field that defines the water net application. We see that a lot of product owners or product developers are working on smart micro systems. We see smart rain barrels. We see smart polder roof systems. And our challenge is to create an application that can connect with all the different devices. And then when we use weather forecast and can foresee stormwater events coming up, we can create maximum storage capacity in those systems.
Yeah. And so that's where we are at with the Things Network right now. So we're developing this, so the Things Network is developing this CPaaS platform, the City Platform as a Service. And on top of that, we're creating this use case of WaterNet application. And yes, there are still many uncertainties, many questions to be answered. So about the data, the privacy, etc. But what we also at the same time see is that there are many contextual market developments that could allow for more demand on those water systems, such as tax differentiation or the so-called water neutral building envelope, which obligates developers to retain their own rainwater at their own plot. These contextual factors will enhance this innovation, and we're happy that we're doing this together with Things Network. And I think we'll leave it at that. So if there are any questions,
feel free.
Feel free.
All right, great. Thanks a lot. I think this is another very good example for like this technology for being used. I think it's also mainly outdoor applications. Yeah. Technology is mainly suitable.
Yeah, it's more on the conceptual level. But I mean, we're developing this in Amsterdam now, but in different cities around the world, they're facing the same problems. So this technology could also enhance their ability to solve the rainwater issues.
Yeah, yeah. And to be clear, can you elaborate a little bit more on like this micromanagement? Is it something I should have on my roof myself in maybe a year from now?
Maybe not in a year, but we're working with different product developers to create a market for such microsystems. Why would you want one? Why would you want a smart rain barrel next to that? It's very fancy, of course. It could help you create maximum storage capacity and the use of rainwater for your garden. But eventually, we're working on things like tax differentiation. So there's another incentive to invest on the public or on the private plot in such systems.
Yeah. So on the one hand, there you have the fun factor, of course, that you're able to control your own rainwater from the beach in Spain, for instance, and to water your garden. On the other hand, there are these incentives to be created in the contextual market.
Yeah, great. Thanks for the elaborate answer. I see one question is popping in now. Since there's a 1% duty cycle, how do you tend to send instructions to all connected roofs?
We're still working on the autonomy of the systems themselves. If they are a bit smart themselves, they don't need a continuous data feed if they're working or not. So that's how we try to keep the data down.
Nice. All right, thanks a lot for the presentation and for all the questions asked. So I'd like to go to the next speaker, and maybe at the end of the presentations we have some more time to discuss some more things around these concepts.
Yes.
So the next speaker, he's sitting next to me, Reinier. Can I put you more in the screen later on? So Reinier, strong technical background. I found out you named inventor at 17 patents. Likely to share this news as well. And maybe very interesting, the concept that you will share with us today has been awarded for the Hackathon Best Product Prize, and even was an IoT award prize as well on a global platform. So
Thank you. I want to thank the ThinkSpeak organization for allowing me some time at this webinar to talk about the Vinduino project. What is it? Let me introduce myself. I am Dutch. I have been living in California for 8 years now. And from a hobby standpoint, I like wine. I like making wine, and it grew into something else. And now I own a vineyard, which is stepping up from the original winemaking from kids. But it's located in the Temecula Valley in Southern California. And if you want to know where that is, because nobody knows Temecula Valley, although it's an official wine region in the US, it's between San Diego and Los Angeles. So that's, so we have a very large crowd. It's Temecula Valley is about 1 hour drive from Los Angeles and San Diego. So a lot of people that don't want to spend the travel time to go to Napa or Sonoma, they go to Temecula. And that area currently has about 35 wineries and 1.3 million visitors each day. So the picture that you see is the picture of the vineyard. And why I am interested in water management is because it doesn't rain enough in Southern California, and the drought didn't help. So just to give you an idea, grapevines need about 20 to 25 inches of rainfall each year. And as you can see in the little table next to it, over the last few years, we just didn't get enough. So you need to irrigate to keep your vines alive and to get some results from growing grapes. So what is the Vinduino project by itself? So Lawrence already mentioned it. It won some prizes. It's basically using an Arduino in a vineyard. So that's how I got to the name Vinduino. And the idea is to measure water moisture, soil moisture at different depth, and just measuring how deep the water drains if you start irrigating. And by stopping the irrigation in time, you can avoid that the water goes too deep where it's beyond the reach of the roots, and thus wasting. So I'm saving over the last 2 years. When I started measuring, I saved about 25% water, which is a lot. I started with a handheld reader and gypsum sensors. And with other growers, we came to the conclusion that what everybody really wants is something that is doing the measurement wirelessly. We started with Wi-Fi, but the range is just not enough. You cannot cover a vineyard or other agricultural crops. So we ended up with using LoRa. Using Arduino and now we're also using Raspberry Pi for a gateway. We really are strong on open source. So the advantage for farmers is that they can save thousands of dollars because it's lower cost. But also there's no vendor lock-in. So the traditional companies that do solutions like this, they basically lock you in. There's no way to talk with other vendors or mix solutions. Once you choose a vendor, then basically you're stuck with them. And with open source, you're not. At this moment, we're offering the Vinduino boards as open source, so the code and the printed circuit board details are on GitHub. And for people who don't want to build it, they can order the printed circuit boards. And we got customers in Argentina, Australia, Brazil, France. I even got Tunisia last week as a customer. So you see that this is spreading all over the world, and it's not just for vineyards. I'm working with a company in Brazil that is supporting coffee growers. Can you imagine? And in all fairness, I like coffee more than wine, or at least I drink more coffee than wine. Let's put it that way. And we're also starting a collaboration with the University of Irvine. They developed a model that simulates how soil moisture develops through the soil, and we're collaborating to calibrate their model. So this is a picture that shows and it's not really getting through as I planned it, but that's the way it works sometimes in technology. If you have a single sensor, then you can basically say it's too dry or too wet, or it's wet enough and you don't need to irrigate. If it's getting too dry, you switch on the irrigation. So that's the system. On the right side, you see multiple sensors, and you see the lowest sensor, sensor number 3, is basically below the root zone. And the idea is that you keep the water in the zone where the active water uptake is from the roots. So what I learned is that more frequent, short duration irrigation actually keeps the water at the higher levels, whereas the standard practice in the vineyard region where I am, it was to irrigate a lot once a week, and that's basically allowing the water to drain below, the root zone, so where it gets wasted. So I'd save about 25% a year, just keeping the water at the level where it's actually being used. This is a picture of the sensor. If you look at the top of the printed circuit boards, you don't see a lot of components. Actually, there's a lot of surface-mounted devices at the back of the board, which you don't see. But no, it's a complicated board, so it's not for the average hobbyist that is used to old-fashioned components like the wired components. SMD is a little bit more elaborate when you start putting PCBs together. So for people who don't want to do that, go to the trouble. The board is there, available. It costs $38, and in the US that includes also shipping. It supports a power management system. So we solved the problem of how do you run an Arduino in low power. There's a real-time clock built in that I can use to keep the power. So it's basically in sleep mode. It wakes up every 50 minutes. Makes a measurement, it powers up the LoRa module, sends the data, and then goes back to sleep again. So that's how we keep the power consumption very low. We use a little solar panel to keep the battery charged. And this unit, this printed circuit board, has inputs for 4 moisture sensors, but it also has additional inputs for air temperature, air humidity. I had somebody who wanted to measure wind speed, for example. So there's a lot of options. If you have a sensor that is supported by Arduino, there's a big chance that you can connect it to this board. On the wireless options, this board standard supports a Wi-Fi module, which is the well-known ESP8266 module. I have LoRaWAN at this moment as a standard, and I'm working with LoRaWAN coming up. So software is available on GitHub, and so is the PCB layout. So this is time for questions. If people have questions, please ask. But if you want to have more information, here's my website address. I think data-driven irrigation is important. It helps you make better irrigation decisions.
Thanks a lot for sharing sharing this story with us. Yeah, thanks a lot for your presentation. I think it's very nice to see that something that started, I think, more or less as a hobby, fun project, now becomes quite a very big thing in your personal life as well. I just saw a question popping in that you were even invited at the university, the Delft University of Technology, to talk about this. So, well, at least something very interesting came out of this already. Let's see if some more questions are popping in already. Maybe in the meantime, I also have a question for you. So you focused on wine. I guess that's from a hobby point of view, but you can imagine that this is applicable to a lot of different agricultural fields.
Yes, so I mentioned coffee. So that was something that came up as somebody in Brazil saw the project and said, "Hey, we have a problem." I saw it on the journal, NOS journal, recently, that there was an issue with coffee beans and the climate change. So hopefully this will help. I know that there is a project in Africa that I really would like to support, but I you know, I need to start somewhere. I need to stay focused. So, but basically, there's a lot of crops that have longer roots, deeper roots, that would profit from this kind of technology. I think the big advantage is, especially for the US, you know, the larger farms can afford to pay for the more expensive systems, but most of the farms in the US are smaller scale, smaller growers, and you know, these kind of technologies have been out of reach to them because they're expensive, they're locked in, they're proprietary, and with open source and connecting it to a LoRa system, I think there's a big opportunity to make it affordable and make it available to more farmers.
Yeah, yeah. Thanks for the answer. Let's see if there are some more questions popping in now. So do you have any idea, I don't know if you have knowledge about that, like how many people are using this open source software?
At this moment, I would say hundreds. In the wine region where I am, this is interesting, by the way. We started with a gateway that can support like 300 stations. I found that farmers want to have their own gateway. They don't care about sharing because they say, well, if my neighbor pulls the plug or does something stupid, I don't have access to my data anymore. So in the Temecula Valley, where we have 35 wineries and more growers, about 200 growers, I installed about 25 stations, sensor stations, and 7 gateways. So it's like, whereas it takes just 2 or 3 gateways to cover the whole wine area. But you know, everybody wants to have their own gateway, and because the gateway is just like $150, that's, yeah. They don't care. They say, well, we want to keep an eye on our data. Yeah.
Great. Well, thanks a lot for sharing.
You're welcome.
I'd like to go to our final speaker for tonight, and then we still have a few minutes left until the end for some final questions. The last speaker for tonight is Andrew Lindsay, working at Thing Innovations. So you have some things to show. So I'm very interested myself as well to see what you have in store for us. That apart from working at the Things Network, you're also the initiator of the Things Network Patchim. So I'd like to give the word to you. And,
okay, thank you. Basically, as you said, I'm the initiator of Things Network Thatcham. Basically, what I'm also been doing is developing a lot of sensors, because it's good enough building the network worldwide, but if you don't have the use cases, you don't have the network to, the sensors on it, what use is it? What I've actually been using is multi-tech M-dots that look like that, pretty small things, or you build them up onto a dev board and it looks like that, and you end up with loads of wires everywhere, and it's not really friendly for doing any sort of really serious use cases work with. What I'm actually doing now is working with a couple of guys in the States called Here Lab. We actually basically came up with a PCB that we're now using in a number of different use cases. One of them we'll come on to in a bit later, but basically this board goes together with the M-dots, and you can just start plugging things in. Plug in a header, various headers, plug in a display, and you've now got something you can carry around with you. Plug in a GPS module, and you can get your position. Plug in a temperature, humidity sensor, and you've now got a handheld device you can carry around with you. This enables you to do site surveys. If you're going to deploy some other sensors, you could use this to detect if you're going to have the range, if your sensors are actually going to work. Moving on to individual use cases for that board, we've included Arduino shield headers, so we can actually plug in a shield here, which is connected to basically a scientific grade probe. And this example is for measuring pH. We can also use alternative probes for measuring dissolved oxygen, conductivity, or ORP. And these could then lead into applications in aquafarming, hydroponics, basic water quality monitoring, all using the same PCB. When you then decide to do something a little bit different, what you can do is, whoops, got a few of these, build the sensor into a nice little indoor sensor. So once you've got it in its enclosure, it can stand up on a wall and be fairly neat looking. And this is all using LoRa backend as well. The recent one, which we've been developing, is actually a presence sensor. That's, I think it's what I was originally asked to talk about. So we're basically using this, exactly the same PCB that we developed and that was used for the handheld device. This has now got a basic PIR connected to it, and that will then sit under a desk or in a room. It can detect the presence, and it basically using the TDN network as its back end to send updates to say that there's been some movement. And this has been trialed in a number of places, particularly for hot desk environments, to monitor the actual usage of these places. It could be used in monitoring the usage of meeting rooms. And it basically, the idea is it's going to sit there for more than weeks, it's going to be months. We're still working out exactly how long the battery is going to last. But it's definitely going to be in the order of months. And it's going to be sending its information in pretty much real time. As opposed to alternative solutions in the occupancy monitoring area that basically take a box, sits under the desk and stays there for a couple of weeks until the battery goes flat. Whereas the beauty of this, it's all online, real time. You can see your information straight away. And one big advantage of using LoRa is that you can put one gateway and it will cover pretty much a whole building. If you then include the cellular option, what you don't do is then tie into the corporate network. This then has a big advantage that you don't need to go through all security approvals, everything to attach another piece of equipment to the company's network. So using the LoRa in this application is pretty much an advantage. Currently, next things moving on is we're actually looking at these, which are the Multitech X-Dot. This is smaller form factor, all surface mount, and we're moving on to a new version of these modules that's so we can then reduce cost, have these built out at a lot cheaper rate. Sorry, forgot what I'm saying. And basically increase the quantity. So basically, it takes it away from the DIY model into sort of in the middle between a complete single unit or single sort of use production device to a multi-use, multi-function device of a sort of commercial quality production device. I think that's about it from me. Any questions?
Thanks a lot for sharing this, Andrew. I think it was quite nice to see as well how like everything looks like, and in fact how simple it is as far as I should follow your story, because it's in fact that simple. Just plug and play some of the sensors, and well, you have a device where you can use for a lot of different purposes. So we got a question here. How many sensors are required per acre on average? Let's see, not really sure what that question is about. Maybe we can give a little bit of more explanation there. So maybe for now on, Andrew, what do you see as the most potential in these kind of devices you're creating?
Sorry, potential for which one? Which particular one?
So I think you create a lot of like devices where you can easily attach a lot of sensors to.
Yeah, we're using them in a lot of different use cases. You've got the handheld one, which is basically a direct competitor to an offering that Multitech have at a much more reduced cost. Basically, these ones, which one's this? This is the water quality sensors. You can also plug in a temperature probe in that. I did have one lying around somewhere, but it's gone missing. And they would just basically dangle in the water, monitoring your fish. They're being used in Martha's Vineyard on the oyster beds there. You can use them in greenhouses if you're monitoring, if you're doing hydroponics with your fish and your plants. We're also looking at a lot of soil moisture, which is actually interesting, following on from the previous speaker, looking to develop a similar solution using pretty much industrial grade water, soil moisture sensors at different levels as well. So I found that quite interesting.
Yeah, nice, thank you. So what do you suggest? How if I want to get started with these kind of devices you're creating, what do you suggest is the best way to get started here?
What with the breakout the basic dev kit there to your own custom PCB. It depends what you want to do. If you want to go for an individual niche product or something that's going to be a bit more universal, which is what I've done with the guys in the States, Here Lab. We've gone for this universal approach that can be easily adapted. The next version is having a few more sensors actually on the board at manufacturing time, because they're all going to be surface mount, basic temperature, humidity, light, and hopefully that's going to be out in the new year sometime. But yeah, definitely getting started. You want to look at something like this, but then the Multitech is not the only platform. You've got a lot of people using the RN2483s from Microchip. And even now with their recent announcement that you can actually put your own code onto those modules. I've not actually tried that yet, but apparently it is possible. And that would then give you an even smaller form factor for a device, which that could be interesting as well.
Yeah, definitely, thank you. And is the software open source?
Not at the minute, although we're looking to, as we roll out the next versions, release the previous version, the version 1s, so other people can use these designs, but sort of keeping a competitive edge. But although we don't see that the next version is going to be sort of DIY friendly, these ones, because they're all through hole, they're very easy to build. It's just put them through, solder them on the back. That's it. They're easy to make yourself. So yeah, the idea is we are going to release the designs and the code for all that probably sometime in the new year.
Thank you. Yeah, great plans are ahead of you as well.
Thank you.
Right, so we have a few more minutes to round off. So maybe there's one or two more questions for any of the presenters. I see your question as well. So do you find that the need to get things CE certified as a barrier to innovation? If anyone wants to respond to this specific question.
I can respond to it for the US. In order to have a commercial product, you need to have FCC approval or these certifications. So for the products that I will bring to market, as you know, if they're like a kit, then you don't need it. But if you want to have a ready-to-use product, then you need to go through this approval. Canada has something alike, and of course there's CE for Europe. So yeah, I think it's an investment, but I think it's a good investment because it also means that you have the documentation and you have the measurements done to avoid compatibility problems.
Thank you for this question. Let's see if there's something others popping up. Maybe also a general question. So what are the biggest, let's say the most difficult things which one of you are facing with developing these kind of products, these kind of use cases? Maybe Dennis or Tjerron or Kasper, maybe has some.
There aren't any real problems. The only thing I see a lot is when I talk to people about LoRa and IoT in general, is that they think that their devices are so important. Those, even if it's a temperature sensor, they say, okay, I need data every second if possible, and for that you simply cannot use LoRa. And I'm trying to convince them to think otherwise about their sensors, because sometimes it takes 2 hours for instance a room to heat up to a certain temperature. So why would you need a temperature measurement every 5 minutes? I mean, it's useless. You can get nice plots, but that's it. So that's a challenge to make people think differently about their sensors.
Yeah, the same accounts for us as well. I mean, whenever it's dry, we don't need actual real-time data every hour or every 5 minutes about our rain barrels or rain buffers. But once the cloudbird hits, it gets interesting to have this more frequent data transmission. But how we can manage that, we're still hesitating. We're not sure about that yet. But so it's about optimizing the system in context of the city, which makes it difficult. And on the other hand, we're also operating at the border of public and private, which makes it a little bit difficult about privacy issues and data, etc., etc.
It's all about the use case we're learning right now with the things.
Yeah, indeed, and being clever with what data you send when, to make it more sustainable and being.
I think one of the issues that one of the previous speakers mentioned was how do you calibrate, how many dust particles you have in the air. For me, it has been how do you calibrate soil moisture. It's been a more challenging task than I imagined when I started off like years ago, and it's still something I'm developing. So calibration and once you have a measurement, what do you do with it? What actions does it trigger, and how do you optimize certain things? So building a network is like the easy part. I'm sorry, but and programming and the electronics, but really making it into a useful use case, that's the challenging part. Yeah. How do you teach farmers to look at their screen and derive from that when you need to irrigate and how long? That's the difficult part. And I think maybe the people who did the air quality can also respond, like, what is the implication if the air quality is not good? What is being done with that information?
Yeah, I think that these low-end air quality measurements will not you will not be able to use that for actual determination of air quality. But you can get, what we did see was that if you have high-grade air quality sensors, then the shape of the measurement is the same. So you can extrapolate from that.
Yeah. Thanks a lot for this. I see we are. It's about time to finish. So maybe Andrew, maybe you have some final words to round off this webinar.
Geez, thanks. No pressure. Yeah. Well, guess actually looking forward to seeing the Kickstarter rewards in the new year. That's going to be the fun time, because you guys have been putting in a lot of hard work on this. So yeah, hopefully that's going to give a big kick to the number of gateways coming along, and more of an adoption of the Things Network throughout the world.
Yeah, I think that's a great end note, because we're about to send 1,500 of those gateways into the world, of which about 40% goes to the Netherlands. And also in the UK, there are quite some gateways being sent to, so that will definitely boost our network, and will result, I believe, in a lot of new use cases that are being developed there worldwide. So that being said, thank you all for your presentations, for taking the time to share with us. Thank you for the viewers that took the time for this webinar. If you have any further thoughts, questions, or anything, we'll open up a forum channel where you can post them, so we can keep the conversation, discussion going. And from now on, I wish you all a good night. Thank you all.